3.1, so the first one in the unit of sequences. So in A, let x sub n be a convergent sequence, so that means it has a limit, and let y sub n be a divergent sequence. What can be said of the product sequence x sub n, y sub n? So let's start with this one, A. Well, what do you think? It actually, you can't say nothing, okay? And I'm going to show it to you using some counterexamples. Okay? So x sub n, you can choose, for instance, 1 over n squared. Okay, this is a convergent sequence. We know it converges to 0, and then y sub n, it could be n. Okay, so the product of x sub n, y sub n is 1 over n, which is convergent. We know. Okay, but we have x sub n is, for instance, 1 over n, and y sub n is n squared. Then the product is n, which is divergent. Okay, but even more, you could have x sub n is minus 1 over n, so minus 1 to the n times 1 over n, and we know this is convergent, it converges to 0, and even though it's an alternating sequence, and then this is y sub n is n. Okay, the product of this is minus 1 to the n, which is minus 1, 1, minus 1, 1, which is neither convergent nor divergent. Okay, so it doesn't diverge to plus or minus infinity, it doesn't converge to anything. So in short, you can't say anything when you have the product of two sequences, okay? Because there are many ways in which a sequence can converge and many ways in which a sequence can diverge. So the product of two things can behave in many different ways too. Okay, so if a sequence of integer numbers is convergent, then what is this sequence like? Okay, so if a sequence is convergent, then that means that the difference between a sub n and a, being a the limit, has to be small enough, okay, smaller than a given number epsilon, for all n after a given number capital N. Okay, so I don't know, you can think of any, so that means that, you know, as you go on increasing your n, there's a point after which, after this n, capital N, the sequence, the difference between this value of a sub n and subsequent and the value a, for instance, the difference can be as small as you want. Okay, so if I pick a given number epsilon, then I can choose, I can find a capital N so that this is true. Okay, so for imagine that I choose epsilon 1 over 2, for instance. Okay, so because the sequence is convergent, we know that after a given n, capital N, for instance, so a n plus 1, a n plus 2, a n plus 3, and so on, they are all are closer to a, the limit, than 1/2. Okay, so this is the definition of the limit. So that means that, you know, if the sequence is you know, formed by integer numbers, this means that these numbers have to be the same as a, right? So because, you know, there are no integers numbers at distance 1/2. Okay, so the distance has to be 1 between two consecutive integer numbers. Okay, so that means that this sequence a sub n is constant. Okay, so this sequence will be something like a sub 1, a sub 2, a sub 3, blah blah blah, and then at some point a sub n, and then at some point after that it has the value a, and up until infinity, and so after that the sequence is constant. Okay, and n could be any value. Okay, from 1 to you know, 1,000, 1 million. Okay, and So now the last one, prove that every convergent sequence is bounded. Okay, so again, so if a sequence is convergent, we have a sub n minus a is smaller than a epsilon for all n greater than a capital N that we have chosen. Okay. Now, if a sequence is bounded, that means that a sub n, the absolute value, is smaller than m, so when m is a real number, for all n. Okay. So now again, as before, if choose some epsilon, for instance. Okay. So let's say epsilon is, I don't know, 1. Then we can choose, we can find an n, we can find n so that, you know, a n plus 1, a n plus 2, and so on, all of these numbers will be closer to, so the difference between them will be, and the limit will be less than 1, so will be closer to a than 1. Okay, so in other words, a sub n minus a smaller than 1. Okay, so now we have that for all these values, we know that there's a bound between, so you know, you have, this is a, okay, and this is a plus 1, and this is a minus 1. We know that for all these values, we know that these points, they have to be in this area. Okay, they can't leave. Okay, so now the sequence after this capital N, okay, so if you write this, a sub n from n equals n plus 1 to infinity is bounded by a plus 1. Okay, it's bounded by a plus 1. Yes, well, it's bounded by a plus 1 and a minus 1 in the minimum. Okay, above, it's bounded above by a plus 1 and bounded below by a minus 1. So what happens to all the numbers in the sequence before that? So what happens to a sub 1, a sub 2, blah blah blah, up to a sub n? Okay, this is a finite set, so we can actually find, let's call capital A is the maximum from n equal to 1 to n of a sub n. Okay, so the maximum of this set, what's the maximum of this set, is this a. Okay, and so well, and we can actually take the maximum of the absolute value of this. Okay, because this is a finite set. Okay, so a is, imagine if we painted these numbers like this. Okay, so a is such that, and this is 0. Okay, a is such that it's greater than the greater number and smaller than minus a is smaller than the smaller number. Okay, and we could actually put the limit a here, but it doesn't matter. Okay, so now we know that the sequence up to capital N is bounded by a, and then after that it's bounded by a plus 1 and a minus 1. So you just need to find this bound, a plus 1. Okay, so before so this is just well, I'm assuming a is a positive number. Okay, otherwise you could do this. Okay, and so now let me erase this. So suppose, I don't know, that the limit a is here. Okay, this is a. So and then so after, and this is n. So after n, we know that the sequence is bounded around here, and before it's bounded around here. Okay, so this is an example, but there's many ways you can do it. If instead of choosing this, we choose a capital A plus 1, so we have this A plus 1, and then here we have minus A minus 1, then we make sure that every number in the sequence is bounded by this number. Okay, so this proves the result. Okay, this is a proper bound for the sequence, and that's it.